Okay, hello everyone, it's Salar and we are in part 27 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I talked about arguments and parameters in function, arguments and parameters, differences, and how your compiler send an argument to your function, okay, with register R0 to R3 from your register bank in your processor and stack frame or activation record in your memory. Okay, you can send some of your arguments in a portion of your stack frame to your function. But in this part, I want to give you some information about local variables in programming. Okay, but what is local variables? As the name implies, local variables is a variable that you can have access to it locally. Okay, for example, here in my main function I have a local variable. Okay, you can have access to this variable, local variable, just in the body of this function. Okay, when you have a local variable in a function, okay, in one function, you can have access to your variable just in the body of your function. Outside of your function, you can't have access to your variable. But a global variable is a variable that's defined outside of a function, okay, and you have access to this variable in all parts of your code. Okay, this is the difference between local variables and global variables. But let's give you an example in Eclipse. Okay, as you can see, I have a code in C programming and I have two functions in my code, main function and function. Okay, and in each of my function I have a local variable. Okay, I've repeated the name of my variable, local variable, and local variable in my functions, but there is no problem because this variable are accessible just in body of function. Okay, so this variable and this variable has identical number, but they are different. Okay, so let's run my code line by line. First, put the value of 20 in my local variable in my main function. As you can see, in my main function, the value of my variable is 20. Let's run next line, and the value of my function is 21. Local variable plus plus. But let's jump to my function, to this function, okay, with a step into bottom. Okay, now the value of my function is not 21 anymore, it's 8. Let's put the value of 30 in that. Okay, as you can see, the value of my variable in my functions are different. Okay, another time, local variable plus plus. But I have a global variable and I have access to my global variable in my function. Okay, the value is 10. As you can see, the value is 10. Okay, inside the function, inside this function. Let's run this line, global variable plus plus. Now the value of global variable is 11. So let's return to main function. I'm in main function, and another time the value of my global variable is 11. And by returning from function, from this function, the value of global variable isn't changed. Okay, another time global variable plus plus, and the value of global variable is 12. Okay, it's different between local variables and global variables. So let's back to our slides. So as I said, a local variable defined inside the function, but a global variable defined outside functions. Okay, so In this slide, I have give you some information about local variables. For example, compilers allocate a portion of the stack frame. Okay, I said in previous part what is a stack frame, to local variables. So you can have your local variables in your stack frame of your function. Okay. After that, a scope of a local variable. What is the scope of a variable? Is where you can have access to your variable, okay, within a function which they are defined. Okay, for example, here my local variable defined in a main function, so scope of this variable is inside main function. Okay, and after existing the function, local variables will be removed, because after existing the function, your compiler and your processor will remove your stack frame, and your local variable is in your stack frame. But okay, as I said in previous part, you will have a copy of some registers in your stack frame or activation record, or you will have your arguments in your activation record or stack frame, and you will have your local variables in stack frame of your function. Let's to give you more information about that with more detail. For example, assume that I have this simple function. The return value is a void, and we have no arguments in our function, but we have an integer value as a local variable in my function. As I said in previous part, your compiler will create your stack frame by these instructions and put the value of 10 in register R3 and save that in this address, R7 relative address. R7 is a stack frame limit address, so you will have your variable in your stack frame. Okay, let's still give you more and more information in this slide. Okay, as you can see, here is my function and here is assembly code that's created by compiler. First, your compiler push the value of R7 in your stack frame. Okay, push the value. After that, calculate the stack frame limit address with this instruction. Okay, but how your compiler compute this number? Okay, 12 with this formula: 0 or 4 plus 8 multiplied by k. 0 when the number of this register that your compiler pushes to a stack frame is a even number. Okay, when the number of these registers is an even number, this number is 0. And when the number of this register is an odd number, for example, here I have just one register and is an odd number, is 4 plus 8 multiplied by k. Okay, for example, here 4 plus 8 multiplied by 1 is 12. 4 because the number of registers are odd and you need a padding. Okay, this 4 is for padding. Okay, and why 8 multiplied by k? Because the stack frame limit address must be a 8-byte aligned number. Okay, so for example, here I have just one integer number, 4-byte number, and I have my variable in my stack frame, and this part of my this 4-byte of my stack frame is unused. Okay, 4-byte for my variable and 4-byte unused, because the stack limit address must be 8-byte aligned number. Okay, or for example, in another example, assume that you have two variables. Okay, two 4-byte variable. Another time this number is 12. 4 plus 8 multiplied by 1 is 12. 4-byte for padding and 8-byte for my variables. Okay, 4 byte for variable 0 and 4 byte for variable 1, and I have no unused cell in my stack frame. Okay, this two instruction for variable 0 and this two instruction for variable 1. Write the value of 10 in stack limit plus 4 plus 0 plus 4 plus 8 plus 12. Write this value variable 0 in stack limit address R7 plus 0 plus 4 and plus 0 for this variable 11. Okay, so your compiler will save your local variables in your stack frame, and when you return from your function you will have not access to your local variables because your compiler and your processor will remove your stack frame. Okay, so let's just see this example in terminal. Okay, as you can see in my function I have two integer variables, variable 0 and variable 1. Let's compile this code and see the object code in terminal. Make project, make object dump. Okay, as you can see with these lines your compiler will create your stack frame, and after that with these two instructions your compiler write the value of variable 0 in your stack frame is R7 relative address, okay, in your stack frame, and with these two instructions write the value of variable 1 in your stack frame. Okay, just like this example. Okay, but let's change our code and add some numbers to my code. For example, var 0 plus plus and variable 1 plus plus. Save that another time, make project and see object done. Okay, another time, as you can see with these instructions your compiler write the value of variable 0 and variable 1 in your stack frame. After that for variable 0 plus plus we have these instructions. Load, in first instruction, load the value of variable 0, variable 0 plus plus, in this instruction add s, and another time store the value of variable 0 plus plus in your stack frame, and these two instructions for variable 1 plus plus. Okay, so this was some information about local variables in ARM processor and what is local variables in C and C++ programming. Okay, compilers allocate a portion of the stack frame, here for local variables. A scope of local variables is within a function which they are defined. Okay, and outside of your function you will have not access to your variable, your local variable, and after existing function local variables will be removed, because after existing functions your compiler will remove your stack frame. Okay, and your local variables are in your stack frame. Okay, this was a short part to define what is local variables, and thank you very much to see me. It's enough for today, and I will see you in the next part. Thank you very much.